A very good evening to Dr. Liu. My name is Shahirah Sabana and I'm going to present my question 1. So the question that I got is this one. So the research question made by the student is whether the body height of student are related to the states. And then this is the data. As you can see, the research question is incomplete as some important terms are missing, and then even the data is not organized properly. So the first thing that I have to do is improve the research question. So then this is the improved one. My research question is there any significant difference in body height in meter of UMS male students from Sabah and Sarawak? Moving on to the experimental design, the response variables are body height in meter and the state of origin of UMS male students. The experimental unit is the UMS male students. The replicates are 14 UMS male students. And the sampling is 7 UMS male students from Sabah and 7 UMS male students from Sarawak. So this is the data organization. As you can see from the question before, the data is not organized properly, so I organized it in a table through Excel, and then I just type it back here. And then I also made a box plot entitled The Difference in Body Height Meter of UMS male students from Sabah and Sarawak through RStudio. So through RStudio, how you can make your box plot, you have to set the working directory. This is the command for setting the working directory. You just have to repeat this, but for this one you have to get the address from the where you store the data. First you have to type the data in Excel and just save it, save as CSV, and then just save it somewhere where you can easily find it. And then you just have to log in the data. You just have to name the object, which is state height. I named the object here state height, and this is the command to read the CSV. To log in the data, this is the command. This is the read CSV, and then this is the name of the file. And don't forget to add the .csv so that the RStudio can read the file. Then once you run this, you can get this one here in the environment, the state height. As you can see, it is the same as the one that I organized in Excel before. You have to make sure it is the same. And then I just to check the data frame, I type str and in open bracket and the name of the object. As you can see, this is the data frame. And then I continue to make the box plot. This is the command for box plot. For box plot, just type box plot, open bracket, the name, the measurement, the name according to, and then the name, $sign, and then the category. And then to change the to add the title, you have to type main equal to the difference in body height. Just type the title. Make sure it is in this sign. And then for the y-axis, you can also change it. And this is for the x-axis. So that's how you got a box plot. You just have to export it as save as image and then do some settings, and then you can save it here. And then moving on to the assumption test. So in order to identify which statistical tests that are suitable for this question, I have to do the normality test. Normality test and test for homogeneity of variance needed to be done in the RStudio. So I just to RStudio. For Shapiro test is for the normality test. So Shapiro needed the subset. We have to examine each subset, not the whole set. So here the whole set is the state height, this one. And I just have to find the subset for the category. So the category is state. So the under it there is Sabah and Sarawak. So first I name the object as Sabah. This is the command for making subset. Just subset the name, the object name, comma. This is the fact, not the fact, the program. The program. So state here because this is Sabah. Sabah is under state, right? Sabah is under state. So double equal sign and then just name it as Sabah. Make sure the name is the same as the one that you wrote in here in the Excel before. Make sure it is the same so that the RStudio can read it. And then for Sarawak, you can just repeat the same command for Sarawak. Make sure the spelling are the same. Both of this, the for the program and for the name. Make sure it's the same as this one so that the R can read it. Or else the R will not be able to read the data. Then there will be 0 observations for the subset. So once you run it, you can get the subset for Sabah. This is the subset for Sabah, and this is the subset for Sarawak. Then we can go ahead and test for the normality test. So just type Shapiro test and then Sabah. So as Shapiro test needed to be done on each subset. So first click Sabah, the dollar sign, and then the measurement, and then just click run. Once you click run, you can see here, this is the result. The p-value is larger than 0.05. So the data is normally distributed. And then for Sarawak, just type the same command, just change the name here to Sarawak. And if you run it, this is the result. And as you can see, the p-value is also larger than 0.05. So the data is normally distributed. So here you can say that the p-value for the normality test is larger than 0.05. Therefore, the data is normally distributed, meaning that so the H null for normality test, the data is normally distributed. So if the p-value is larger than 0.05, we have to accept the null hypothesis. So the data is normally distributed for this test. And then for the test for homogeneity of variance, you can also do it in R. So in R, you have to type library or card. You have to install the package. This one is you have to install the package by yourself. You can do some can think help. No, but you can find in Google on how to install the car package. So just have to type the library car, and then you can proceed to do the live-in test. Live-in test is a test for the homogeneity of variance. So just type live-in test. This one, make sure the spelling is correct. Open bracket, and this is the name. So for live-in test, it does not need any subset. So you can just have the whole set of data. The dollar sign, and the measurement. Dollar sign and the measurement. And then according to the name, and then dollar sign, and then the category, which is the state. So if you run it, then you can get here. This is the answer for 11 tests. This is the result for 11 tests. And as you can see, the p-value is 1. So it is larger than 0.05, meaning that the variance between sample is equal, as the null hypothesis for test for homogeneity of variance is the variance between sample is equal. So if the p-value is larger than 0.05, then we have to accept the H null. So the variance between sample is equal. So moving on, as you already did the assumption test, so now we can proceed with the statistical test. So for this test, for this question, I'm using the two independent sample t-test because the data is normally distributed and the variance between samples is equal. Both data, which is the body height and state, are independent of each other, and the body height is continuous data while state is categorical data. Hence, it fits all the assumptions for two independent sample t-tests. This is the statistical hypothesis. So for the H null, there is no significant difference in body height in meter of UMS male students from Sabah and Sarawak. For the alternative hypothesis, the alternate hypothesis, there is a significant difference in body height in meter of UMS male students from Sabah and Sarawak. Moving on, we have to set the criteria. So the criteria is alpha equal to 0.05. So as we already chose the statistical test, which is the two independent sample t-test, we can run it in the R. So for the t-test, we have to type this command. This is the command for t-test. T-test, open bracket, and then the name of the object, the dollar sign, the measurement, which is the body height, according to the name, dollar sign, and then the category, which is state, and then alternative two-sided. We the test for the data here, the as it is a t-test, so it is two-sided, and it is not a paired t-test, so this is false, and then the variance are equal, which is true. So we just have to run it, and if you run it, you can get this answer. This is the result. And as you can see here, the p-value have exponent sign, meaning that it is smaller than 0.05. You can see here the p-value is smaller. Therefore, as p-value is less than a critical value, which is 0.05, therefore we reject the H null. H null, we reject that there is no significant difference in body height of UMS male students from Sabah and Sarawak. So the conclusion is the two independent sample t-tests inferred that there is a significant difference between body height of UMS male students from Sabah and Sarawak. This is the result that you can get from R to run the t-test. And then the p-value is smaller than the critical value, which is 0.05, thus indicating that there is a significant difference in body height of UMS male students from Sabah and Sarawak. Thank you.